This video is on algebraic proofs. Let's start by recalling the steps necessary to solve an equation. So we have the equation 4x minus 7 equals negative 11. Most of you like to separate your equation with a line where the equal sign is, so you don't get the left and the right side sort of mixed up together. So start there, and remember that if you forget what to do first, when we solve an equation, we're working PEMDAS backwards. So any addition and subtraction in the problem, we have to take care of first. We have this x, and our goal is to get it all by itself. So I see that there's a minus 7, and I need to get rid of it. So to do that, I'm going to do the opposite, or inverse operation, and I'm going to add 7. What I do to one side, I do to the other. So when you complete that step, you get 4x, these cancel, you still have your equal sign, and now negative 11 plus 7 is negative 4. All right, we have 4x equals negative 4. Let me ask you, how did you get that? What did you do to get to this next step in the equation? What we did was add to both sides. So I'm just going to put addition here so that we have a note about what we did to get here. All right, now let's look at this part, and we've done all the addition and subtraction we could do. I see that x, in order to get it by itself, I have a 4 by it, and that means that it's being multiplied since it's just right in front of it. The inverse operation of multiplication, the opposite, is division. And so whatever's in front of the x, you divide by that. But what you do to one side, of course you do to the other. Now 4 over 4 is 1, so 1x is just x. And don't lose your equal sign, it goes where your line is. Negative 4 over 4 can be reduced, and that is negative 1. Be careful with your signs, use your calculator if you need to. Now before you say, okay, I'm done, let's look back and see what we did to get to this step. How did we get here, x equals negative 1? Well, the last thing I did, the very last thing, was divide both sides by 4. And so next to this, I'm going to make a note that I did division. Your answer is x equals negative 1. And I've actually proven it by justifying each step with what I did to get there. So I started with the equation that I was given. I did some addition and ended up with this second line here, 4x equals negative 4. And then I did some division and I ended up with my answer, x equals negative 1. And you can see that I noted that I did division to get there. Let's take a look at one for you to do. I want you to try this one, and after you do each step, I want you to remember to answer the question why, or how did I get this? What did you do to get to that step? So just like we did on the last screen. Pause the video now and give it a shot. Okay, how did you do? Did you get x equals negative 6? If you did, great, and I want you to look back at the steps and see if you justified each step correctly. The first thing you did was subtract 8. Once you finished subtracting 8 from both sides, you got this second step here, negative 3x equals 18. That was the result of subtracting, and so you got there for the reason that you subtracted. That's how you got it. And then you knew that you had to divide by whatever is in front of the x. I hope you didn't lose the negative there. And you divide both sides by negative 3. The result is x equals negative 6. You got that by dividing, and so your reason for being able to write x equals -6 is division. So you're always saying how you got there. All right, a mathematical proof. It's a formal and logical way of proving that something is true. It uses information that you're given and then just math rules or properties to justify every step you take toward your goal. In this case, your goal is the correct answer. We use proofs in this course, coordinate algebra, to prove that we're solving an equation using only the allowed math rules or properties in order to get the correct answer. Next year in analytic geometry, you'll use proofs to prove things like similar or congruent triangles, and you'll use logical reasoning and allowed math rules, properties, and also theorems or definitions. So what you see at the bottom of the screen is what a two-column proof looks like. And two columns because there's two columns. The first column is for statements, and the second column is for reasons. So the steps we fill in are really just the same that we did without this proof table. Look at the example on the screen. We started with 5x plus 6 equals 8, and that was given to us. That's the given problem. Now, if you look at the second statement, it says 5x equals -2. If you take a look, think about how they got this from this. What was the first thing you would have done to solve this equation in line number 1? Wouldn't you have subtracted 6 from both sides? And when you did, those would go away, and 8 minus 6, whoops, it looks like there's a mistake here. 8 minus 6 is positive 2, and this should be a positive. I apologize for the mistake. So when that's the case, 5x equals 2 came by subtracting 6 from both sides. And so look, the reason is the subtraction property. That's an actual property in math that says if you subtract something from one side of the equation, you have to subtract it from the other side. And as long as you do it to both sides, you're allowed to do it. All right? And so here you are at statement 2, 5x equals 2. What would you do next to solve this equation? I hope you said that you divide both sides by 5. Because when you do, the 5 over 5 cancels, and look, you get line 3, x equals 2/5. And of course, that was supposed to be positive. So the reason you were allowed to say x equals 2/5 is because you were allowed to divide 5 as long as you did it to both sides of the equation. And since you did, we call that the division property. Notice that the statements are the math steps. Notice that the reasons are always some rule or property, and it's really just the word, what you did. You never really knew it as a rule or a property. You just knew what I do to one side, I do to the other. We've been telling you that for years. And so really, if you subtracted, write subtraction property. If you added, write addition property. And the same thing if you multiplied or divided. Whatever you did, whether you realize it or not, all these years you've been solving equations, it is math properties, and that is your reason. You're going to answer the question basically, how did I get this? And the answer will be your reason. You'll see some equations that are harder to solve later today or tomorrow if you're watching this the night before. So here are some tips, some common things that are going to come up. The first one is that you may have a fraction or fractions in your problem. To get rid of fractions, I want you to multiply every term, every single piece of this equation, both sides of the equal sign, by the denominator, the bottom of that fraction. It feels like magic when you do it. I'm telling you, it is math and the fractions will disappear. And how many of you actually like working with the fractions? So follow my advice, and of course, I'll help you do a few problems in class. The second thing that's going to come up is when you have more than one term with an x in it on the same side of the equal sign. If that happens, you need to combine like terms. And so if it's 2x plus 3x, you combine them, you write 5x. If it's 6x minus 2x, you combine them, you write 4x. And again, we'll go over problems like this. There are other types of problems that you'll see, but let's focus on a few for now. Don't worry, we're going to practice some of these together in class.